Hello, welcome to Math with Mr. Dobrescu, to the rescue. Scientific notation. Why do you think we need to write numbers in scientific notation? And the reason is, sometimes we have large numbers that will take lots of space on a paper that we need to comprise to write them in scientific notation to save us some space. So sometimes we have to write numbers in scientific notation. For example, this number is written in scientific notation. Okay, it doesn't take that much space. Okay, let's take a look at the definition of scientific notation. A number is written in scientific notation when it is represented as a product of a factor and the power of 10. So a product of a factor and a power of 10. The factor must be greater than or equal to 1. The factor must be greater than or equal to 1 and less than 10. So take a look at this number here, 8.3. 8 is greater than 1 and less than 10. And you see that we have the decimal between 8 and 3. So a scientific notation number the decimal point has to be placed after the first number, between the first number and the second number. And then we have sometimes 10 to either a negative exponent or a positive exponent. And then we can say that the number is written in scientific notation. And then the exponent, the power of 10, has an integer exponent. So that's the requirement. The power of 10 has to be an integer, not a fraction, an integer, either positive or a negative number. Okay, let's take a look at some examples now. So now we need to write these numbers in standard form. So we can either write the numbers in standard form, or we can write the numbers in scientific notation. Today we are going to practice writing numbers in standard form. Okay, so we have a number here. Write 3.22 times 10 to the negative 4. And of course, this is written in scientific notation, again, because the decimal point is placed between the first and the second number. And then we have times 10 to an integer exponent, negative 4. Okay, but we need to write that in the standard form. So let's look at the definition for standard form. If the exponent is negative, like we have here, and like we have here, if the exponent is negative, move the decimal point to the left. So we are going to move this decimal point to the left. Okay, how many places the exponent is telling us? So let's rewrite the number again. 3.22. Okay, and now we are going to move the decimal, right? Move the decimal point. So let's move the decimal point to the left 4 places, because that's 10 to the negative 4. This is telling us, the exponent is telling us how many places we need to move to the left. So 1, 2, 3, and 4. And after we do that, we are going to place some zeros for all those places. 1 0 here, 1 0 here, and another 0 here. And then we are going to place the decimal is going to be placed right here. And then eventually we're going to have another 0 right here. So now the number is going to be written as this. 0 point, decimal has moved there now. 0, 0, 0, 3, 2, 2. And this is our final answer. Okay, so now we wrote this number that is in scientific notation in the standard form. Okay, you see it takes a little bit longer. Standard form takes longer than this, right? So it's expanded and it's in standard form. So again, to turn that in standard form, if the exponent is negative, we are moving to the left. Okay, move the decimal point to the left. Let's take a look at another example here. So here we have 3.85 times 10 to the negative 8. And again, this is also written in scientific notation because the decimal point is placed between 3 and 8. And it is times 10 to a negative exponent, to an integer. So let's start with 3.85. And again here, we have to move the decimal to the left. How many places here? 8 places. So let's go. 1, 2, 3, 4, 5, 6, 7, 8. So now we are going to place zeros. 1, 2, 3, 4, 5, 6, 7, 0. And then put the decimal right here and add another 0. And this number becomes now, 0 point, all bunch of zeros. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then 3, 8, 5. And now we can say we are done. So again, you see that the standard form takes quite a bit of space to write it on a piece of paper, and the scientific notation takes less space. That's why sometimes we have to write numbers in scientific notations. But now they are asking us to write these numbers in standard form, so then we have to move to the left 8 places and we are done. So the number is 0.00000000385. Let's take a look at these examples now. When we have the exponent being, the power being positive, what's going to happen if we need to write this in standard form? So, if the exponent is positive, move the decimal point to the right. So now instead of moving it to the left, we are going to move the decimal point to the right, according to how many places the exponent is telling us. So let's take a look at this number here. So the first number here, we have 7.9. And now we are going to move 5 places to the right instead, because this is positive. So we have 1, 2, 3, 4, 5. Don't forget to add those zeros. 1, 2, 3, 4 zeros now. That's it. So the number is going to be 79 followed by 4 zeros. 1, 2, 3, 4. And again, we go from the end 3 places. So this is 790,000. Okay? And this is the standard form. This is the scientific notation. It means 790,000. And this is the standard form. Let's take a look at the second example here. Here we have 1.66. And here is telling us, this exponent is telling us that we need to move the decimal point 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. And let's add those zeros. 1, 2, 3, 4, 5, 6, 7 zeros. And our final answer would be 166. Sorry, that was supposed to be a 6. Okay? So 166 followed by 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7 zeros. 1, 2, 3, 4, 5, 6, 7 zeros. And then let's count from the end. 3 places, and another 3 places, right? So this is quite a large number written in standard form. That would be here would be a million, and we are getting into billions now, right? It's a large number written in the standard form. You see the different standard form scientific notation. I hope you guys are clear how to convert the numbers. If the exponents are negative, please remember that we are moving the decimal point to the left. Negative, we move to the left. Okay, pay attention to this. We move to the left according to the exponent. Okay, and of course, if the exponent is positive, instead of going to the left, we are going to the right according to the exponent. Thank you all so much for watching, and I hope this makes it really clear for you how to convert the numbers from scientific notation to standard form. And again, if the exponent is negative, we are moving to the left. the decimal point, and if the exponent is positive, we are moving the decimal point to the right. Thank you all so much again, and please don't forget to like and subscribe, and I'll see you in the next video. All the best to you.